Okay, so we can start this session. And the session again will be on how to solve the circuits by using equivalence circuits. So we will start from this description that is a Cascode amplifier. Cascode means we have this transistor here, and to this terminal, drain terminal, we have another transistor connected to it. If it would have been connected to the gate, then it's called as cascade. So this is a cascode system. The parameter values which we will require in solving these questions are given. VDE on, that is, this is my VD, this is my E, so this VDE is given, and this VDE is also given, and it's equivalent to 0.6 volt. Also, VC sat 1 is equivalent to C sat 2, equivalent to 0.3 volt. Beta 1, that would be, let's call it for now as ICQ2 divided by IB2, and beta 2 as ICQ1 by IB1. Okay. Early voltage is also given, which will be required to calculate lambda. Assume the source resistance of amplifier is 1.73 kilo ohm, and thermal equivalent is given also as 26 millivolt. The values of components of the amplifier, as these are the components, which are used in bias the circuits. Assume the value of C3 is very high. Where is C3? Here, this one. Okay. The values of parasitic capacitance of both transistors are given as these are the parasitic capacitors. The supply voltage is also given. High bias, which is this current, is 1.8 milliampere. Find the small signal out resistance of the circuit, amplifier circuit. So we need to find the output resistance. That is, since this is our output, we need to find the output resistance. So what is our step? Our first step is to draw an equivalent circuit. Okay, so be careful. We have two transistors. Let me start with Q1. Okay, so we start with Q1. And let's call this terminal as a let's say this terminal has a potential of V1. Okay, all right. So now to draw the circuit for Q1, we will have. We can start from here because we need to further draw the Set it for Q2 as well. This is the inference equations for the first BJT. This will be its emitter terminal. What is this? GM1. And this is B. So this will be BA1. Since early voltages are given, we can write here as R01. And mention that let's call this potential as V1. So we will have a potential of V1 here. Now this node is connected to the emitter terminal of Q2. Let's first draw its gate connections. We will have this grounded because the AC signal is not there. So we will have R1 parallel R2, right? Sorry, not R1 parallel R2. This is R3 parallel R4. These are the not R3, it's R2. So R2 parallel R4. And then we will have its intrinsic resistance of R by 2, its emitter, which is connected to the node V1. Then we will have simple circuit of, let's call this as B. So we will have B equal R not 2. Okay. And then we will have finally a load resistance of R3. And this node is V out. Now what we need to do is we need to find the output resistance. If we want to make it easier, what we will do is we'll calculate this resistance. Let's call this as R dash and then find total output resistance as alright. So this will be the procedure. I hope you can do on your own as well. I suggest first you try to find yourself, stop the video, and then check how it can be solved. So this is the equivalent circuit. So let's now solve this. We need to find R dash. First, let's check few of the values. GM1 will be equivalent to GM2 is equivalent to, see, because all the parameters are same for these transistors. R01 will be early voltage V1 by AC. IC, same, I'm taking a same IC because the same current flows through the transistors in series. One second. So this will be R node 1 and R node 2 will be okay. I hope audio is coming clearly. Hello, everyone. Okay. And R phi 1 will be equivalent to GM1 by B1 and R phi 2 will be equivalent to GM2 by beta 2. So you need to calculate these values, calculate the output resistance. So now first let's calculate IB1 first. IB1 is the current going in the base terminal of transistor Q1, right? Since this C1 blocks the DC path, what I can do is check now across the R1. So this IB1 flows through this terminal, sorry, this resistor, IB1, and follows this path. Since there is a capacitor C1, it blocks this capacitance, sorry, it blocks this current, so the whole current goes in this direction. So I can write here IB1 is VCC minus, because it has a potential of VBE1 on by R1. VCC is 12 volt and this is given as 0.6. R1 is 760 kilo ohm. If we calculate it, let's use the calculator. It will be 760 or 15 microamperes. Okay. Therefore, IC1 will be beta 1 multiplied by IB1, and beta 1 is 120 multiplied by 15 microamperes. How much is that? Comes out to be 1.8 milliampere. So this is IC1. Since IC1 will be equivalent to IC2, 1.8 milliampere. Therefore, GM1 will be equivalent to GM2 will be equivalent to 1.8 milli by VT, which is 26 milli, is equivalent to 9 by 13 Siemens. Let's keep it as well. And we have R by 1, R by 2 as beta 1 by GM1 is equivalent to 120 multiplied by 30 Let's keep it in this form. And this is beta 2 by GM2, which is again 240 by 9 multiplied by 130, which is equivalent to 10400 by 3 ohms. Also, we can calculate now R1, R01 and R02 as, because early voltages are equal 120 volt. So we have VA by IC. So this is 120 to 1.8 milli, and it comes out to be 400 by 3 kilo ohm. So these are the values which we may need to solve the questions. Get the values. Now we have these. What was the main motive? Calculate the output resistance. Let's say we have connected test source with potential Vx and current Ix, and this is a potential V1 here, this node. So let's do the nodal analysis. At output node. So we will have plus the transistor current, that is GM2 VDV2, and it will be equivalent to Ix. This is the current coming in is equivalent to current going out. Now for transistor Q2, V2. So this will be minus V1 because V2 is V1. Right? V2 is, this is V2, V2, V1, A1. So I can write Vx by R02 minus V1 by R02 minus Gm V1 is equivalent to Ix. Okay. Now we need to find V1. Now, if we have to find V1, we need to find this resistance. Alright. Let's just again understand this. Okay. So if I just quickly draw here for E2, this is E2 terminal and this is R01. Since this is grounded, and we have left with R by 2, so this will have a resistance of R by 2. So the total resistance here, because this output resistance point, this transistor is here R01. So we will have total resistance R1, R01 parallel R by 2. So V1, let me just write it here. V1 is the potential, and since current of Ix will come through this node because current coming in has to go out. So we will have V1 as Ix times R01 parallel R by 2. Therefore, Vx by R02 minus Ix R01 parallel R by 2 divided by R02 minus Gm Ix R01 parallel R by 2 is equivalent to Ix. Let's transpose these two terms to right hand side. We get therefore R out will be given by Vx by Ix will be equivalent to R0 will go here. So this will be basically R01 parallel R by 2 plus Gm R02 multiplied by R01 parallel R0 R by 2 plus R02. So this is not total R0 R out, so we just denoted it as R dash earlier. So R out will be this R dash multiplied by from the circuit. This is R3. So this is total output. Okay. So check the steps from this equivalent circuit and see if you got the same values. Just substitute the values and see if you get the right answer.
Okay, let me just give the values. R out comes out to be 6.04 mega. Please check if you are getting the same answer. If not, just let me know in the forum or in the comments in the YouTube section. Okay, so let's move on. Okay, mic is working. Let's move on to this part. We need to find a DC voltage V output between collector Q2 and the ground terminal for the amplifier circuit as shown below. Okay, we need to use the same figure. Assume that the mismatch in the collector current Q1 and IB1 is ignorable. Okay, enter the closest answer. So let's see the circuit. Here it is the circuit. This is my V output. We need to find this voltage, right? So this is the same voltage which will be across R out. So what we have is I can we just calculated R out, which was sorry, this is not R out, R dash. We calculated R dash, right? We calculated R dash because R dash is the resistance. Let me clear here. This is R dash. Here I have written R dash. Okay. So the output resistance R dash. See here R dash and R3 are connected. Okay. You are looking in this terminal to calculate R dash. So we have a voltage divider. So therefore, V output will be simply R dash divided by R dash plus R3 multiplied by VCC. And from the previous part, you substitute the values which we have calculated, and you'll see the R dash comes out to be 15 mega. We just need to calculate that, and therefore V output will be 15 mega. There will be 15 mega plus R3. What is R3? 10 mega. 10 mega multiplied by VCC, which is 12. This is 15 by 25 multiplied by 12. Okay. 7.2 volt. So this is how you can calculate in this section. I hope it's easy. Okay, let's move on. And we know mid-frequency range is the range in which we simply calculate the gain by shorting the input resistance and creating output load capacitances as open. Okay, So if I now draw the equivalent circuit, we will have Vs here, a series resistance. What else do we have? We have a series resistance Rs, the resistance of R1 and R5. No need to draw R2 parallel R4 because it's anyway AC grounded from both sides. But we need to draw GM. So this is your equivalent circuit. We need to find, let's again call this as V1. We need to find V naught, V output by V in. That's your V source here. Let's call this V. So we need to find this. First, what we will do, we will find okay. So this will be the procedure. So what are our steps? Simple again. Model analysis. At output node. What do we have? This is our output node. I have the output by R3 plus the output by R02 we have the output by R3 plus the difference of potential, that is V output minus Vn across R02 plus current leaving, that is VB2. Again, VB2 is 0, therefore VB2 is 0 minus VB2, and here VB2 is V1. Therefore, it will be V output by R3 plus V output by R02, V1 by R02 plus V1 GM. I'm writing GM because both the GM will be same. So this will be GMV1. Alright. So what do we have? One by R3 plus okay, or V output will be V1 R3 1 plus GM R02 divided by R02 plus R. So we found the first step, the relation between V output and V1. Now next is V1 in terms of V in. So let me just redraw the circuit, only this part. So we have basically so if I take nodal analysis at this node here, so I can write V1 by R01 plus GM VBE1 is 0. So V1 is GM R01 VB1 minus VE1. Here VE1 is 0 and VB1 will be given by voltage divider R1 parallel R by 1 divided by R1 parallel R by 1 plus Rs multiplied by V in. So let me call this as alpha V in. So VB1 is alpha times V in. So shooting it in V1, so V1 will be minus GM R0 times alpha times V in. So this is my relation of V1 in terms of V. I missed one thing here, and that's very important. We will have another resistor here, R dash, and this R dash, let me just what will be this R dash? What is R dash? R dash is the resistance looking into the emitter terminal of Q2. So it's basically, if I draw the equivalent circuit, this will be grounded, and we have a test source of Vx Ix. So I can write Ix as Ix plus Gm VBE2 as Vx sorry, there is no source connected here, so I can count it. So this is basically V out. So this will be Vx minus V out by R naught 2. And also, so V out is equivalent to Ix times Rs. Because this is the current flowing through this terminal. Therefore, Ix, this will be minus Gm times Vx, will be Vx by R naught minus Ix R. This is this R3. Ix R3 by R naught 2. So I have everything in terms of Ix and Vx. Let's just simplify it. So we will have here Ix as 1 plus R3 by R naught 2, and here Vx as Gm plus 1 by R naught 2. So R naught 2, this will be Ix R naught 2 plus R3 and Vx 1 plus Gm R naught 2. So Vx by Ix will be, and this should be your R dash. Okay. So now when we have this R dash, now we are in a position to calculate V1 in terms of V in. So now nodal analysis at output node will be V1 by R3 plus V1 by R naught 1, sorry, not R3, R dash. This is rounded R naught 1 plus Gm VBE1 will be equivalent to 0. So V1 divided by 1 by R dash plus 1 by R naught 1, it will be equivalent to minus Gm VBE1. So we will have VB1 minus VE1, which is 0, and we know VB1 will be R1 parallel R by 1 divided by R1 parallel R by 1 plus Rs multiplied by V in. So let's call it alpha times V in. So this will be minus Gm times alpha times V in. So V1 will be equivalent to R dash parallel R naught 1 times Gm alpha V in. So this is my relation of V1 in terms of V in. So now what we need to do is, so this is my relation, and from the previous steps I calculated here, you just need to substitute here for V1 and you will get the V output in terms of V in. I hope that was understood. Okay, now we need to find the input capacitance of the amplifier as shown in figure 8.1. Let's look at the figure. So this is my figure, and for this part I need to draw the equivalent circuit. Let me quickly draw the equivalent circuit. C phi 1, this is C mu 1 here. So now you should be really able to draw the equivalent circuits. Now almost in every session I solve the questions using the equivalent circuit. So it should be very easy now. I hope so. So my input capacitance is this. This is my effective input capacitance. And for the question to solve, we use a Miller's theorem. I didn't draw the cascoded answer because we don't need that here. So from Miller's theorem, total input capacitance will be C pi 1 plus C mu 1, 1 minus. Here we just need the gain of the first transistor only, AV1. And AV1, if I directly write it now, it will be minus times GM 1 R naught 1 parallel. The equivalent resistance we calculated in the previous section, and that included, did that include R pi? Okay. There may be a mistake here. Okay, we can ignore that. What you need to do is total R dash, and this you calculated this R dash, and there should be another resistor which happens to be, okay, forget it. So in this part, you should correct it. Here, if you look here, we have two paths here, one here and one here. So I have not taken alpha into consideration. What we will do is total resistance, let's call this R double dash, will be R dash parallel R by 2. So let me just note it down that it is R double dash here. Okay, so this is my total. So here also it will be a double dash multiplied by alpha times. This will be alpha. Yes, this is alpha. And when you calculate it, it will come out to be minus 90.5. You substitute it here, and you will have the values for C pi and C mu1 given in the question, and you will get an answer of 467 picofarad. Calculate it, let me know in the comments or in the forum if you have any doubts. Okay, we have a question on cutoff frequencies. How do we calculate that? Let's say this is 1, 2 pi. This is a common formula, and let me just write it down. 2 pi. So we have the capacitance. Let's say I am using the C input capacitance, and what I need now is a total. Since we are calculating the upper cutoff frequency, so we are not concerned with C1 because that will be the lower cutoff frequency. And now I'm trying to check what will be the cutoff frequency for this capacitor C input. I will check what is the total resistance across it. So if this is my C input effective, I will see short this C1, short this source. You will see your RS1, sorry, R1 and R1 in parallel. So this is your R net. So R net here, and R net is R1 parallel R1 parallel RS. So this is your R net, and you calculate it, get a frequency, and check how. And another one is with the load capacitance CL. And for load capacitance, we will use R out. Now let me know which R out. Let's go back to the first part. See, okay. So when you calculate R out here, it is the output resistance looking into the drain terminal. So it should be R dash parallel R3, which we calculated here, this R out, and which is 6.04 mega ohm. Use this value and get the answer in this part. We have calculated this R out as well. So let me just, no, okay, you can just calculate it and let me know if you can find the answer. Okay, so let's say now we have a different set of question. Again, we have cascoded system. Just check the question for now. Okay, so I have again a cascode system of MOSFETs now, and we have these parameters given. Okay, let's just directly jump to the question. Find the DC gate voltage of M2. Okay, so the concept here we will use that in a cascoded system, same current flows. So IM1 will be equivalent to IM2. Okay. And what will be the gate voltage for M1 transistor? That's called as GM1. That's simply given by the voltage divider R2 divided by R1 plus R2 multiplied by VDD. And R2 is 30 and R1 is 90 kilo ohm. So this is 30K divided by 30K plus 90K multiplied by 12, that is VDD. And it will come out to be 30K by 120K multiplied by 12K and K will cancel 0 and 12 and this will be 3. This is your gate voltage first. Next we'll do is calculate the drain current. Treating the transfer in saturation, drain current is given as, let's call this as VGS1 and VTHN whole square. And kW by L is zero point 0.5 milli. So this is 0.5 milli by 2, and this will calculate as 3, and the threshold voltage is given as 1, and it comes out to be 1 milliamp. So ISD, that is for the, now for transistor, ISD, because it's a PMOS, AW by L, VSD2 whole square. And here Vs is VDD, which is 12 volt. VG2 we need to calculate, which is given in the question. Alright. So 1 milli is equivalent to 0.5 milli by 2. 12 minus VG2 minus 1 whole square. Milli and milli will cancel. 1 second. Oh, this is 2 milli. So we have basically 12 minus VG2 minus 1 equivalent to plus minus 1. So minus 11 plus minus 1, which will give you VG2 as either 12 volt or VG2 as 10. So which one is the correct? Since Vs is 12 volt, so we cannot have Vg equal to 12 volt because Vg will be 0, the transistor will not be on. We have an answer here as 10. So this will be your gate voltage for transistor. Okay, find the value of R4 such that the same current is flowing through transistor M1 and M2 as shown in the figure. So we will use a concept again that IDS1 is equivalent to ISD2. But now we need to use another information which is given in the question, that is channeling modulation. So IDS, which is KW by 2L n times, right? So this is VGS1 minus VTHN whole square 1 plus lambda 1 times VDS. And here VDS is V out. This one, this term. This is VDS for M1 and it's also equivalent to V out. So writing it down, ISD2 is KW by 2LK VSG2 minus VTHP mod whole square, and again 1 plus lambda 2 times VSD2. So equating the two, you will get KW by L. Let me just substitute the values. On the left hand side, we have for the transistor and MOS, and this is VGS1 minus VTHS3 minus 1 is 4, and this will be 1 plus, let me just write this, lambda 1, this is 2, this will be equal to 1 milli, and this is 2 milli by 2, and again this will be VSG1, that is 12 minus 10, that will be 2, 2 minus, and what is VTHP, and this is 1, so this will be 1 whole square, but we have a multiply VSD, that is 12 minus V out. So now we get an equation in terms of 1 plus lambda 1 V out is equivalent to 1 plus 12 times lambda 2 minus lambda 2 V out. We have values of lambda 1, lambda 2. We need just find V out, which comes out to be 7.2 volt, right? So we need this value because we need to find the value of R. Now looking at the circuit, what we can do is the current coming in is the current going out, because this is the base, so we are assuming a very less current here. So we can write a Ohm's law here, write VDD minus, this is a gate terminal 2, so VG2 by R3, it will be equivalent to VG2 minus V output of divided by R4. So in this way we can calculate R4. VDD is 12 minus 10 by R3. R3 is given 60K, and VG2 again 10 minus 7.2 by R4. Yeah. So this is 2 by 60K multiply R4 is equivalent to 10, and this is 2.8. Okay. Therefore R4 comes out to be 2.8 multiplied by 60. This is 1.4. This would be 4. So it's 1.4. 14 multiplied by 60. So it comes out to be 84. This is how we build R4. And then Where do I paste this? Okay, let me just rewrite it quickly. So we have VGD minus VG2 divided by R3 is equal to VG2 minus V output by R2. This is 12 minus 10 by 60k is equal to 10 minus 10. So R4 is 4.8 multiplied by 63 equal to 2. This comes out to be 84. This is how you can solve. And again, this question is saying, over the screen, frequency range. I'm not drawing the equivalent circuit for this. You should now be able to draw it, and we are going to calculate it again. What is the information? Okay, let me just draw it quickly. R1 parallel R2, the answer first, and we have GVN. Look here, this VGD will be grounded, this will be grounded, and these R3 and R4 will be in series. Assuming that there is an infinite resistance here. And we have our resistance looking into this terminal, calculated as Rn. And this is equal to. And how do you calculate Rm2? You have Ix, Vx, Gm, Vsg2, R02. Calculate it, and you will get a gain of minus Gm 1, R0 1 parallel R3 plus R4 parallel Rm. Calculate the values of everything. R0 1 will be given by 1 by lambda 1 times ID, where ID is 1 milliampere. So we just have single unknown. Gm can be calculated from your transfer equation. Okay. R3, R4 is given, R1 is now calculated, Rm you have to calculate from this equivalent circuit method, which I frequently use and find the answer. Input capacitance. Again, if I draw the circuit, I will get the input effective capacitance as CGS plus CGD times 1 minus AV1. Right? Once you calculate from the previous part, you will find that AV1 is 0.27. Therefore, C input effective CGS is given in the question as 10 pico, CGD is 5 pico. which is 10 pico plus 5 pico, 1 minus minus 27. It turns out to be. The next question will be, yes, what a frequency. So you need to find that. You can find that now, right? That is easy now. You have the values of input capacitance. Similarly, you can find output capacitance. That would be C load plus CGD multiplied by 1 minus 1 by 8. So this is all for the today's session. So we had a cascoded system. We learned how to draw the equivalent circuits and then also solve the several things like how to find out capacitance of the equivalent circuit, how to find its gain. So this is a good practice. You can I guess you should be able to now. We should be able to now draw the equivalent circuits or complex circuits. So that will make it easier for you to solve these type of questions. If you have any questions, you can always send a message or comment on the YouTube or on the phone. Okay, I guess that's it. Let me close the session.